Okay, so thanks everybody.
Welcome to the last talk for today, Pushing the Limits with ReactPHP. First of all, the slides are in English. Would anybody here like me to not talk in German? Okay, a few hands. Okay, I think I'll stick to English then. It's only fair. Okay, so let me start. Today's agenda is we are going to introduce ourselves, and then we're going to get a very short introduction into React. But the core part of this demonstration, which is now gone, there it is again. The core part is actually demos, live demos, lots of live demos, and live demos tend to go wrong. So please bear with me if something doesn't work as expected. So let me start with saying hello. My name is Christian Lück, and many people don't know the U in my last name, so I usually go by Lück. And that makes up for my initials, which is Clue, which is my GitHub handle. And on Twitter, this was already taken. That makes me another Clue there. So in case you want to treat, this is my handle. So I could tell you all day long what I did, but I think what's most important about me is that I'm passionate about pushing the limits. And this is also why I choose this topic. I choose this as my master's thesis, and I also choose this because I actually believe in this topic, and I hope to share this passion. And this is what this is all about, to spread the idea of how this can be used. And I happen to be a freelance software engineer, so if you like the topic, please come and talk to me. So who are you? Please raise your hand. Who considers themselves a PHP developer? And I hope like every single hand is going up. OK, that's a good thing. Who knows React? This one. We've heard it a couple of times today. Many people. I'm afraid I have to tell you this talk is not about this React. It's about this React. It's either way the other React, depending on how you call. Some people call it the one without licensing issues, or I prefer the real React because we actually had the name first, but then Facebook came and yeah, that's it. So this is the real React. So let's start with a very short introduction. Okay, what does your average PHP application look like? PHP, is it actually the web of the 90s? So in a traditional LAMP stack, you end up with a client, your web server, your PHP process, and perhaps a relational database that are interconnected. And if PHP looks too slow, there are a couple of ways to improve the situation. For example, we can spawn multiple PHP processes, or we can use an Nginx instead of Apache, or we can use a cache solution such as Memcache or Redis, for example. And this leads us to PHP may not be pretty, but in fact, it gets the job done. That's why we all are here. We are here because we help businesses earn money. PHP gets the job done. PHP is a very powerful product. But knock knock, who's here? Like I said, this is essentially the web of the 90s, and nowadays we have 2017, and we have changed demands. Thanks for the follow, by the way. Nowadays we have separation of concerns. This wasn't an issue back in 1990s. We have RESTful APIs, HTTP-based APIs which integrate into third-party applications such as GitHub or any other license. We have live data, we have CLI tools. So the whole infrastructure looks completely different. And when people consider these new constraints, they often say, okay, why not use Node.js instead? And this talk is, the main idea is basically, how about instead of using Node.js, let's use Node.js. And that's it. Let's dive into React, the real React. OK, so what is React? In short terms, it's non-blocking I/O, it's event-driven, it's asynchronous. But wait, in other words, 100% pure PHP, no extensions, no magic, and it runs everywhere. But OK, let's slow this down. What does it even mean? So here's the basic idea of ReactPHP. The idea is very simple. It's essentially calculations are very fast. Your CPU is very fast, but input-output is slow. I/O is always slow in comparison. But the bad thing about this is, oh my god, this looks terrible. I/O is everywhere. Let's face it. There's no way we can avoid input-output, because input-output, if we talk about third-party applications, like we said, third-party integrations, you're going to end up with input-output operations. Even if you're using a local database, such as MySQL, Postgres, if it's in your same network, or even if it's on the same machine, you still use input-output operations to communicate, to send queries, to receive data. And even if you try to improve this and use file system, you may not even notice this, such as the session files. You also use input-output operations to the file system. You can use, for example, a cache, but again, also if you're using Redis or Memcache, you also end up with input-output operation to your cache. Your cache may be fast, but you still use input-output operations. So the thing is, input-output is everywhere, and that kind of sucks. To put this into numbers, and this looks so much better on my screen, promise. Don't worry, you don't have to recall every single number, but the basic idea is the top is what happens within the CPU, and it's really fast. It's measured in nanoseconds. And if we step down, like reading from RAM, or reading from a local database, from network, or across the ocean, you end up with several orders of magnitude slower. So we end up with 150 milliseconds. So this is huge. And in short, this means input-output is slow, let's face it. But why wait? If we accept the fact that input-output is slow, how about we do something else in the time instead of waiting? And this is React, this is the basic idea. So you can start multiple input-output operations. You just start them, and this is non-blocking. And then you get a notification whenever something interesting happens. OK, there's new data, here's your result. You react to things. Also, that's why it got its name. And this means we don't have to waste any time waiting unless we want to. OK, so now we have a very rough idea of what React is. What React is not. It's essentially not black magic. It's not voodoo. It doesn't make your code faster automatically. You have to take advantage of its new paradigm to use it. It's not a framework, which also means it's not going to replace your favorite framework. If you're using Symfony or whatever, you're fine. You can still continue using it. React is not an alternative to this. And React is not the new buzz, it's here to stay. It started like 5 years ago. We had our 5th anniversary this year. And this means this is not some prototype magic. This is actually used in production. So let's look into the 3 core components of ReactPHP. And this is going to be really quick, because I only want to give you the basic idea. There's essentially the event loop, which is the core low-level component. And the basic idea is, as a consumer, you don't care about it. You create it once, you pass it around, and you start it once. That's it. And in code, this means it looks pretty much like this. And you don't really care. It's kind of everywhere, but you don't really have to care about it. From the implementer's perspective, this implements the Reactor Pattern, which is also why it got its name. And it allows you to start timers, to get a notification, OK, in 10 seconds run this function. And this example is going to print hello world, obviously. And you can use it to listen on streams, to get a notification, OK, new data is there. But this is really low level, so you pretty much don't end up using it anyway, because you use the streams abstraction on top. Streams are an abstraction for everything that could be large. For example, think of a download. You probably don't want to store a 1 GB file in memory, but each individual chunk is kind of small. So this can be easily expressed as a readable stream. And streams can be either readable, such as a download, or they can be writable if you're writing something to a file on your disk, or they can be duplex, such as TCP/IP connection, where you can receive data and send data back. And in code, again, this means something like this. This is probably going to look familiar to people who have already used Node.js. You can write on a stream, you can get a notification when new data is incoming, notification when the stream closes. These are the main events that happen. And because they all share a common interface, this allows to build us such things as using a source stream without actually knowing what this does. You can kind of grasp the concept. You pipe the source into a gunzip, you get the the unzipped resulting stream, you pipe it into a bad words filter, which removes certain words, and then pipe it into a destination. And you don't really have to care about what the source or the destination is. At least you only know that the source has to be readable and the destination has to be writable, and that's it. So this is abstraction number 2. Abstraction number 3 is promises. Promises. Who has used promises before in JavaScript, for example? Okay, about half of you. Basic idea is it's a placeholder. Whenever you start an operation, you get back a placeholder that can be used to get a notification when it's done. And this placeholder can have 3 states. It's either pending, so the operation is still going on, or you get a notification when it's fulfilled, you have a successful result, or you get a rejection when an exception happens. This operation is not going to be fulfilled because of an error. And this is probably what it's going to look like. You can use a promise, and then when something happens, you call the process function, or you can pass a second function which is called when an error happens. So this is promises. And this is pretty much it for the code side, because I actually want to focus on showing this in production, or how can we show this in practical use. So let's start with the first example and hope for the demo gods to be on our side today. Let me check if I can reach the internet. I can, that's a good thing. So the first example is a socket server. A socket server is essentially the canonical example for demoing input-output operations. This means you can send a message to it and it broadcasts a message to everybody who's connected. So everybody who has a laptop in range is invited to join my demo in case it works. In case it doesn't work, I'm going to chat with myself. So this is the idea. Let me start the demo and see if I can get this running. Example chat server. And start this on port 6001. So the thing is, you could essentially use my IP address, but it's blocked in this Wi-Fi network. So I use a reverse tunneling into the internet, so you can connect back to it. And this means if you use telnet to outpost, you're going to end up on my machine. Let's see if anybody's going to join. And just say hi. Yay. Apparently somebody used it in the browser, because we see an HTTP request. OK, there it is. So people actually share. Sorry. OK, let's get back to the demonstration quickly. Welcome to my chat server. And let's look at the code. OK, how much code does this involve? I'd better be quick. So this is ReactPHP socket. Sorry. ReactPHP socket examples number 2. And this is basically it. You see some boilerplate code at the top. And then the core, like I said, you create the loop once. You start a server that is listening for connections. And then below here, when a new connection comes in, and then when on this connection new data comes in, strip some bad words, such as binary data, so you don't mess with the demo. And then at the bottom, loop over each client and send it back. So this is what this code is going to look like. And this is like 10 or 15 lines of code, and we're going to see this later again in the demos. OK, so this is a chat server. A chat server is kind of boring, let's face it. So let's look into higher level protocols. There's of course also an HTTP client, which allows you to send HTTP requests and get HTTP responses back. It's inspired by Chris Waldsmith's Bus. That's why it's called Bus React. And by the way, all those slides happen to be links to the respective repositories. So if you check the slides later. It's PSR7 compatible, which means you can use it pretty much like any client, except that it's asynchronous, which means you can send multiple requests in parallel. And I promise you it's fast, and how fast it's going to be, I'll show you in a couple of slides later. So, but again, an HTTP client is kind of low level. When we think about third-party applications, we think of third-party APIs, such as packages, for example. So in this case, we can use the packages API to query information about packages. And it uses this HTTP client under the hood. And so we can look into what this code is going to look like. Yeah. Packages. And there's an example. And if we execute it, we see 2 printouts quite fast, and the last one is going to take some time. You see the order has changed. Let's look into the code, what this actually does. So here again, a bit of boilerplate at the top. There's the loop. You create it once, you pass it around, and you don't care about it. And then you have your actual API interface. And in this case, you issue a search. And then when the results come in, you process this. So in this case, I'm going to print out the number of results only. And if you look below, I actually also query 2 packages from myself. And if you remember the output, I actually started the search first and then 2 queries, but the order of results actually changed because the search took longest, and I'm going to receive it at the last position. So this is what a promise-based API could look like as an example. So back to the slides. Again, I promise you to show a benchmark how fast this HTTP client can be, but it's kind of hard to benchmark against third-party applications such as packages API, because you probably don't want to hit any limits there. So in this case, how about using Docker? Who has used Docker before? Okay, that's a good thing. First time I gave this talk, like 5 people raised their hand. You should definitely check Docker out, it's cool. So the basic idea is you can put applications into isolated containers that look kind of like virtual machines, but are not. That's the basic idea. And it allows you to, the idea is to ship these containers everywhere. So they theoretically run everywhere. And the cool thing about Docker is if you run it on your laptop, you actually run a Docker daemon, which allows you to spawn new Docker containers. And this Docker daemon is actually controlled through an HTTP API. So this means you can send an HTTP request against Docker to spawn a new lightweight virtual machine. And this means there's, of course, a Docker client, which allows you to spawn these processes, and this can be used to benchmark the whole thing. So let's run the benchmarks. For example, again, I can run example info, and I get some information from my Docker daemon, which shows number of CPUs and number of containers and everything. And we can look at this again. Looks very similar to the packages example. It essentially executes an info, and here's some boilerplate with the loop. You create it once, you pass it around, and you run it at the bottom. And here we only execute an info command, and when the info is received, we essentially print it out. So let's make this a bit more interesting. How about running the benchmark example? So what this benchmark example is going to do, if I run it, I'm going to get an error. Oh, it works because I already have it running below here. Sorry. Here it is. So I actually start a new container and then use the benchmarking example to pipe data into this container and receive it back. And I actually receive it back with almost 700 megabytes per second, which is quite fast, in my opinion. And the interesting thing about this is 700 megabytes, it's megabytes, it's not megabit. So it's much faster than your average network connection, for example. And the very cool thing about this is my Docker daemon maxed out. PHP did not. So if I run this benchmark again and look at my process utilization, I see that PHP is taking above approximately 50%, and Docker is using 100% of my CPU, which means that if Docker would be faster, my benchmark results would be higher. So it's not PHP that is too slow, which is kind of interesting, I think. So this is the client side. So let's look at the server side. There's also an HTTP server. It's written in pure PHP, no additional web server whatsoever, and it also uses standards PSR7 interfaces. And last week we also got standards compatible middleware interfaces, which is cool because we also heard a middleware talk today. And this server has lots of third-party integrations into existing frameworks, so you can start using it. I don't recommend using this as of yet because it's still under active development, but it's actually quite cool to give this a spin. And yeah, so what kind of benchmarking results could we possibly expect from an HTTP server? For example, if we use a very bare-bone Hello World example and use this against Apache or Nginx, how many requests per second could we possibly execute with a very simple PHP Hello World example? Let's say about 10 milliseconds per request, which means about 100 requests per second, in other words. We can, of course, spawn 10 processes in parallel, so we end up with like 1,000 requests per second, which is kind of fast for a PHP-based server. But if we run this benchmark, we actually get about 5,000 requests per second on my laptop, which is a very mediocre i3 CPU. And when I first saw this number, I was quite surprised, to be honest. But I did the math. And this is running on a single core of my CPU. I can use this. I have a dual core CPU in this case, so I can actually execute 10,000 requests per second. And why I think this number is really interesting is because I gave this talk at Typo conference, T3DD, sorry. And there was somebody from Google Cloud Engineering, and he had a talk, how can we execute, I don't recall the exact number, it was like, how can we execute 30 million requests per hour? How much software does it require to serve 30 million requests per hour? And if we do the math here, we can actually execute 36 million requests per hour on my laptop, which means my laptop outperforms the Google Cloud Engine, which is quite impressive. To be fair, it's just an Hello World example. But okay, so this is just an HTTP server. Let's make this more interesting. I could show you a demo how you can send an HTTP request. You're going to see in Hello World, it's kind of boring. Let's look into service and events. Okay, who here has worked with event source? And I'm not talking about event sourcing. Yeah. Okay, this is cool. It's a single hand raise up. Nobody knows about event source. I don't know why. So the basic idea is event source is kind of like an alternative to WebSockets, but it only works into a single direction. So you can only receive data from the web server. You cannot send data back to the web server. It's a really simple protocol. It has limited browser support, which essentially means it runs everywhere except for Microsoft-based browsers. But there's a polyfill, so you can actually use it on pretty much any browser if you want. And we can so we saw the demo application that allows us to chat in the console, and now we can use an HTTP server and server-send events to actually push this into the browser. So if we're going to execute our plain text chat on port 6002, and this is going to connect to port 6001, which is still running. And this means if I'm now going to open my browser, let's see if I can 602. Okay, somebody connected, which would be me. So is anybody still connected to the chat demo and dares to send a message? Or I'm going to chat with myself. I don't mind. Let's see who's faster. Ah, you win. Okay, so I actually see the same messages in my browser window that are still ending up below here. So let's look into how much code does this involve. Yeah, everybody's seeing this, and the cool thing about this is it. Yeah. Okay, this is it. You only start a new event source. It's a browser-based API, so you don't have to import any kind of third-party scripts. You essentially pass an URL here. In this case, it's going to be demo. And whenever a new message comes in, you append it to your body. So a proper chat example is not going to look like this. You probably have some kind of CSS and HTML structure around it. But the cool thing is, it looks very similar to the stream application that we saw for ReactPHP. So it's actually doing very similar things. So let's start a stylish chat example. And this is what the chat application could look like. Where is it? Okay, let's reload this. One more try. Yeah. Okay. My screen is still working. How about you all come and look here? Okay. Okay, hi. I can send messages. Yeah, it actually works. So, sorry, I want to show the code. Again, it's very similar. You still have the core is still, you start an event source. When a new message comes in, you append it to your body. This is still the core of it. There's a bit more JavaScript for interaction and user interface. And this is pretty much it. So this is event source. Of course, the alternative would be a WebSocket server. There's also a WebSocket server, which is Ratchet by Boden, which is the one WebSocket server you're probably going to use if you use a PHP-based WebSocket server. It works equally well. Has better browser support because Microsoft supports this standard, but it would pretty much show the same result. So I'm going to skip this. So we talked about caching. And if we want to access our cache, in this case, let's start with the Redis client. There's also a Redis client available for ReactPHP. Who has worked with Redis? Raise your hands. OK. About 20%, I think. The idea is it's a very fast in-memory database. It has very simple commands. It doesn't support things like structured query language, just very simple get value or set key value. And that's pretty much it. And this allows us to build a Redis client in PHP. Workspace PHP Redis. Sorry, already prepared this below here. So you can run an increment, and it's always going to show the next number. If we're going to look at the source code, again, we see a similar structure, some boilerplate at the top. With a loop, you pass it around, then you create your client, you send an increment command, you send a get command, and when the result is received, you print out the result, and then you start the loop. So this is what Redis client could look like. So who knows what language the Redis server is written in? Or who has any ideas what language you would possibly choose for a Redis server? So the answer is kind of obvious. It's a C-based server because performance matters. But for some reason, there's also the official Redis server is written in C, but for some reason there's also a re-implementation in pure PHP. Somebody with the name Clue ended up writing a whole database server in just PHP. And the cool thing about this is it's actually very simple to add new commands. It's essentially using a public function, and if your public function accepts a single argument, this is going to be your Redis command. But let's be serious. Okay, how fast could this possibly be? And of course, the cool thing about Redis, it actually comes with a benchmark, so you can run the benchmark against the official Redis server, and then against my PHP Redis server. So I ran the benchmark on my very, very mediocre laptop, and the official server ended up with about 90,000 requests per second, which is okay-ish, but not so good. And I reran the same benchmark against my laptop, and what kind of result would you expect from a PHP-based database server? 20 requests or 20K? 20K, I wouldn't have expected 20K, to be honest, but the actual result was 50K, which means, in short, this is pure PHP. Who needs native code anyway? So we achieved almost half of the performance of a highly tuned C-based program. So how about we rewrite everything in PHP instead? Okay, let's be serious, don't do that, ever. And one of the cool things that actually came out of this Redis server, the thing is I actually didn't want to write a Redis server. I kind of ended up writing a Redis server because I only wanted to test my Redis client, so I had to mock the server, and suddenly I had a fully functional working server because it's actually really simple. The cool thing about this, I started to extract a framework, which is still a development preview because I only work on it when I'm at conferences for some reason. And we can look at this Redis framework, which allows you to build your own Redis server. So if you carefully look below here, I actually started the whole examples against my Redis server. I also could have started this against an official Redis server. Okay, so let's see the Redis framework. There's an example called ping. And Redis is really simple. So I can connect with just telnet, 6839. And if I send ping, I get a pong message back. That's about it. That's the Redis protocol. I can send hello, and it says, okay, I don't know this command, because there's no hello command. So let's look into the source code of this ping example. Again, some boilerplate at the top. And here it is. Whenever a new command comes in and the command is ping, write back a pong status message. Otherwise, print unknown or disabled command. So below here, this was running against my Redis server. I could also use a Docker-based Redis server, which is the official server. So if I rerun the same thing again, just to prove it, I actually get the same pong message. So, but it's kind of boring to re-implement existing commands. So how about using it to implement new commands? So what would be the first command that comes to mind? Let's look into this example first for a second. Okay, just first example. So you can now connect to this again if you're fast enough. Let's see, outpost 6003. So is anybody trying to connect to the Redis beer server? Because if I send ping, it says, sorry, we only serve beer. Get beer. Get wine. But there's the secret command called beer. There you go. Beer. Okay, I was too fast, because this is my business logic. My business logic does not allow me to execute this command too fast. And eventually I'm going to run out of beer and I'm going to get a new message. So if we look at this source code, it's again very simple. So if the command is not beer, I'm going to reject it, and otherwise I'm going to reduce the number of beers, say there you go, and otherwise, sorry, no more beers. This is the whole thing. And the cool thing about this is you probably won't end up writing a beer command for Redis. But the cool thing is there are a number of integration points into Redis. So you can execute Redis commands from the command line. You can use Redis commands from within Python. And Python doesn't have to know what kind of Redis server is actually listening there, as long as it's speaking the Redis protocol. So you can actually implement custom logic on the server side without actually using a Redis server at all. And you can serve beer. So this is the Redis server. There are also a number of tools such as Sanity, which allows you to build a graphical user interface in PHP. It's very simple, it's promise-based, and it's very cool. And the very short demo is, are you sure you want to proceed? And you can actually react to it, and when you say, OK, then show this dialog, you can show list dialogues. So you could actually use a graphical composer installer, for example. Or how about using a graphical interface for 5? That would be pretty awesome. OK, so there are many, many more third-party projects. This is just trying to give you a very quick overview because we're running out of time. So let's make some very short conclusions. PHP is faster than you probably thought. PHP is hardly ever the bottleneck. PHP is more versatile than you probably thought. It allows you to build some pretty cool stuff, which most people probably don't associate with PHP at all. ReactPHP is a real deal. Let's face it. It is production ready and is here to stay. It has existed for 5 years. People have used it in production for almost 5 years. And I hope they are going to continue using it in 5 years. It has over 20 million downloads, so it's actually not just a toy project. And download statistics suggest installs are through the whole week and not at the weekend, which I think is a good sign. Yeah, it's stable and production ready. So it's awesome and you should use it. Please try it. And the basic thing is consider trying it whenever you have to wait or whenever you're having to access the network. Also had some cool discussion about a debel or RMM, how this actually just sends commands to the database. This is accessing the network. This would be a perfect fit for ReactPHP. So if you need help, check the README, check the open issues, join us on IRC, tweet us at ReactPHP, use the hashtag ReactPHP, talk to me. Please talk to me because did I mention I'm available? I'm a freelance software engineer. Please talk to me. So thank you for your attention, and I have plenty of ReactPHP stickers here, so if you have any questions, and then come to me. Thank you.
Are there any questions? No? Nobody? Ah, great.
Hello. How does the non-blocking work? How does the non-blocking thing work in ReactPHP? Do you use some library, pthreads or so?
The cool thing about ReactPHP, like I said, it actually doesn't use any extensions at all. So it actually still runs with PHP 5.3, which we do not recommend. Please use PHP 7+. It actually uses only stream-based APIs. Everything has always been there. There's a stream select function call, there's stream set blocking function call, but it's all hidden below our APIs, so you don't have to care about it. But this is the core, stream select and stream set non-blocking.
More questions? Okay.
No more questions. Don't forget to come for the stickers. They're very rare, I hear.
I come for the gift. So,
Okay. Thank you.
for a photo, please.